你进来了吗？看到我吗 ？Ted。Hello。Hello, Neil. Can you hear me? Hello, can you hear me? Hey Ted， 我听不到你的声音哎。听不到。哎，你听得到我？
有，我这个应该有声音了吧？
啊，我听到了，我听到了。
是很清楚的还是？
啊，是很清楚。
OK， 好。好，你这边看到有谁进来吗？
你看到我吗？画面？
我看得到你的 PowerPoint。PowerPoint
也看得到是吧？人看得到吗？
看得到。
你看得到我人啊？
对，人跟 PowerPoint 都看得到。
但是 attendee 的话，我看，哎 ，Neil 刚刚上来，但是我看不到他。
我这边看不出有谁参加，对不对？
对，照理说看得到。他又下去了，刚刚那个 Coral 又下去了，不知道为什么。Raymond 上来 ，Raymond， 但是问号。
哎，哦，没事。
Hello Raymond, can you hear me? Hello.诶，为什么他们都听不到他们声音？太冷。
那我问他 ，Can you hear?
What's like? Can you hear me now?
Yes, we can hear you.
Yes, I can hear you, Raymond.
Morning.
Hello.
How are you, Edward? How are you?
Yeah, how are you doing? Yeah, I'm fine. Yeah, can you
Good, thank you.
And the presentation slide.
Okay.
Can you see my screenshot and the presentation slide?
Yes, I can see it. I can see everything.
Okay,
Good.
no problem. Yeah.
Good. And everyone will just log in now. We're going to use the boardroom, but we have another meeting on at the moment. So
Okay.
we'll just tune in as we go.
Okay. So we will wait for them for a while. Okay. So we will wait for several minutes. Okay.
Okay, 100%. Thank you.
Yeah.
How many people will join this meeting today?
Well, Edward Bass is about 10, 11 people. So we'll be joining. I've sent invites out to some of my university contacts. I've asked them to please join if they can. You know, it's with the lockdown, some of them are at home, some are at the office. So it's all dependable if they've got any internet or anything at home. So let's hope some of them join in.
Okay. Understand.
I've sent about 12, 13 invites out to the universities.
Okay.
Okay. Well, I think after this, if you can send me something on a video, maybe if they haven't joined in, I can just forward this through to them. You know, as an information video, and follow up with them on it, and yeah, take it from there.
Yes, actually, we will have a record. We will record the video. Yeah, after the meeting, we will send the video file to all of you guys. Okay.
Okay. Okay. Thank you very much.
So Ted, I hope you can start. Have a start speech. Okay, Ted.
Okay. Thank you for your all join to our webinar today. And today we will talk about VNA topic. So today, if you have any question, please don't hesitate to raise your hand or type your question in the right hand communication box. So we can see what is your question, and we will answer your question immediately. Okay. So please, Edward, let's start our lesson.
Okay. So now we will start this session today. So thank you all you guys to attend this meeting. So we are very glad and very happy to have this session and to deliver the new product presentation and new product introduction to all you guys in South Africa. Yeah, so actually 4 years ago, I have experience to visit the South Africa with our previous sales guy. Yeah, so during many years, I cannot go to the South Africa. So I think we can also deliver the presentation through the webinar in the future. Yeah, so if you have any further technical questions in the future, welcome to discuss with me or Ted. Yeah, so we will help you to resolve the technical or sales issues in the future. Yeah, so today I will introduce for the first. So I'm Edward. Yeah, I'm Edward Pan, and my office is in Taipei City in Taiwan. So I am in charge of the technical marketing sessions in the Regal company. Yeah, our headquarters is in Suzhou, mainland China. So Ted and I are locating at the Taipei City. So we are in charge of the international sales business from the before to now. So today I will introduce you a new product options, that is the VNA, that is the Vector Network Analyzer. Yeah, options inside the real-time spectral analyzer. Yeah, as you know that the Regal always emphasis on the middle and the entry level the test and measurement instrument. So, but now for the recent years, we are go upward to the higher end model. test and measurement instruments, such as the oscilloscope and the real-time spectral analyzer. So today, I will have several sessions. Yeah, and I will not go through detailed in the very fundamental detailed for the network analysis. I think all you guys are very familiar with the principles of network analysis. So I will have a brief introduction to the principles of the network analysis. I will focus more on the key applications of the vector network analysis analyzer. And for the third session, I will have you introduction to the Regal's new network analyzer options inside the RSA5000 and the 3000 series. And finally, I will deliver a brief demonstration through the camera to help you to know more detail about our new product options. Okay. So now we go through for the first sessions. What types devices are tested by the network analyzer? So it is very simple. The network analyzer focuses more on the passive components. So the passive components belongs to the radio frequency or microwave sessions. So we can see from the left hand side, yeah, this is all kinds of the passive components belongs to the RF application area. Yeah, so we can starting from the passive component such as some kind of the isolator, cables, filters, or some kind of the transmission line, waveguide, and we can also upgrade the component level upward to the antennas or some kind of the active device, such as the receiver or the amplifiers. So we can, if you want to inspect or verify the performance of the passive component, we can use by the network analyzer. So what is the network analyzer? So basically, the network analyzer means a radio frequency circuit network. It's not the local area network. That is not the Wi-Fi or the 4G or 5G network in the world. So that is the electronic component system network. Yeah, so it is used to analyze the reflection or transmission parameters of the circuit and the impedance matching performance between the RF devices. So the network analyzer can separate for two kind of categories. One is the scalar type, the other is the vector type. So for the scalar type, that is a very traditional type that only included some kind of information of the gain, voltage standing wave, or the power loss, but it does not have the phase or delay information. But for the vector type, it can have some information about the phase delay and such as the S parameters, Smith chart or the polar chart, group delay, or some kind of the distance to fault information in advance. So if we are going to the basic theory or the principle of the network analyzer, you can treat it as a optical transmission theory. Yeah, so if you can see the principles, if you have a light incident to a lens, optical lens, it has a reflected part and transmitted part. So if we get the reflected part data and to get the transmitted data, and after the calculation with the incident data, yeah, that can get the S11 and S21 information in further. Yeah, so it is the same as the RF microwave component. If we send some kind of a signal, incident signal, it will get some part of the reflected signal and transmitted signal. So why do we need to test the components? Yeah, because we need to verify the specifications of the building blocks for more complex RF systems, and some kind of the distortion is the transmission of the communication signals, including the component linearities or the non-linearities characteristics, yeah, including the harmonics, intermodulation, compression, or AM to PM conversion. And we can also assure better impedance matching when absorbing the power. Yeah. So it is the key characterization of the linear network. So we can get some of the information such as the S parameters, Smith chart, or device modeling information, or time domain characterization. For the time domain characterization, that means it is also called the TDR information. That is the time domain reflector information. Yeah. So we can also get the vector error correction information in further. Yeah. So the parameters of the VNA, the first one we need to emphasize, put more emphasis on the data is the scattering parameters. So you can see this is the key component located in the middle. And if you send the signals by the two terminal from the left side or from the right side, we can get the reflection part and the transmission part. At the contrary, we also can get the transmission part and the reflection part by the reverse the reflection part. So totally we can get 4 elements of the matrix in the matrix that can get the S11, S22, S21, and S12. So the second one information we can highlight is the reflective parameters. Yeah, because it belongs to many complicated mathematical formula. So I will not go through for detail about the theoretically calculation of the parameters. So you can refer to this information as a reference. So that is impedance matching information. So we need to get more information about the impedance or the impedance match or the admittance information. Yeah. So this is the Smith chart. So if you put more emphasis on the Smith chart, you can get more real part and the imaginary part information from the Smith chart to observe some kind of information to judge for if the system can have a good impedance matching between the RF components. Yeah. So if you want to measure the transmission parameters, you can get the transmission coefficient or the gain or insertion loss or the insertion phase shift information. Yeah. That is the phase also calculated by the transmission parameters. It is the group delay. So for the group delay, it is also called the phenomena of the dispersion. Yeah, for the dispersion, that is can refer to the optical side or the RF communication side. Yeah, because if you transmit the microwave group, the signal wave, so it will have a group delay beyond to different kind of the dielectric media or the intermediate phase. Yeah. So the final one is the distance to fault calculation. That is means the TDR application as well. Yeah, it's a time domain reflector. Yeah. So because as you know, we have a tracking generator inside the real-time spectral analyzer, so we can treat it as a tracking signal and send the signal to the RF component or the cable. and we can, if the signal encountered an interrupt point, so it will have a reflection wave, and we can calculate the position of the wave and to get the cable's length information and the position of the default point in advance. So for the second session, we will go for the key application of the vector network analyzer. So what is the key application we will address for? So we can see the current, we have many hot topics among the market, such as the 5G communication. Yeah, so we can separate for 4 categories. Yeah, so the first one is we can address for the base station verification or the IoT, Internet of Things, or the Internet of Vehicles, or the auto driving system. So we can address for the component test, standing wave test of the antenna, or the transmission fault judgment by the cable or the transmission system. And we can also use the vector work analysis system to do some kind of impedance matching or debugging performance verification in further. So the first one is the antenna verification. As you know, the antenna has dedicated the resonance frequency point as the key resonant point. So in a wireless communication system, if you want to verify if the power can be transferred from the circuit through the antenna and going outside, broadcast to outside, it must to verify the VSWR parameters in advance, because the VSWR indicates the performance of the antenna first. So we can also verify the antenna standing wave ratio and impedance matching parameters. The second one is the point to the fault, point of the fault, that we can definite the location of abnormal connection components in communication system, and we can find the cable fault points and the quality testing in further. Yeah. The third one is the component test. So for a component test, we can separate it for 2 categories. The first one is the active device. The second one is the passive device. So the active device means it can carry on the power, yeah, and have an active device performance that we can get the power gain, device linearities, and the response flatness, or the key items of the verification, and the S11 return loss, VSWR. For the passive component characteristic test, we can verify for some kind of the S21 or the insertion loss, phase delay, group delay, such as this kind of the vector type parameters verification. The final one is the impedance matching. The impedance matching, we can separate it for 2 levels. The first one is the system level, and the second one is the component level. The system levels using the parameters test diagrams of the real and imaginary parts of the Smith chart can help the system engineer to optimize the signal to produce the maximum power transfer. And the component level impedance matching, that is also only use the Smith chart with the transmission line reflection theory to calculate the best measurement value of the impedance matching adjustment and can be obtained. Yeah. So after these 2 sessions, so I think I don't know if you all you guys have any questions. If you have any questions, don't hesitate to raise up at the right-hand side of the display, or or if you have any questions, you can raise up immediately. So any questions?
Nothing at this stage, Edward.
Okay.
You can carry on. You can carry on that side.
Okay, no problem. So I will
much.
go through for the very important part is the introduction to the new Rego's network and analyzer options. Yeah, that is called the RSA5000N and the 3000N signal analyzer. Yeah. So this option is based on the real-time spectrum analyzer. Yeah, so we have several kind of the application mode under the real-time spectrum analyzer. Yeah. So this is the specifications for the RSA5000 series signal analyzer. So we have the ultra real technologies, and the frequency can be up to 6.5 gigahertz, and the nano can be down to minus 165 dBm, and the phase noise can be down to a minus 108 dBc per hertz. And we have the minimum, the RBW value can be down to 1 hertz, and we have 40 megahertz real-time analysis bandwidth. And we have the vector signal analysis demodulation options and EMI. And finally, we have the latest new one, that is the VNA measurement applications. So if you want to have the VNA applications options, you need to quote the RSA5000N model here, and the 3000N, this is the 3000N here. Yeah, the 3000, the key specifications on the 5000 and the 3000N is almost the same compared to the previous 5000 and 3000 series. Yeah. So this is the key features of the network analyzer options here. Yeah, so you can see the key specifications is the same as the spectrum analyzer. So we can do the S11, S21, or the distance to fault applications. And the measurement bandwidth can be up to 10 megahertz. Yeah, and we can have the dynamic range can be down to 80 dB, and the correlated directivity can be larger than 40 dB. Yeah. So the unique ones, we have to expand the product portfolio to the 3015N series. You can see this one. Yeah, because as you know, we have the previously we have the RSA800 series, the spectral analyzer, and we have the 815 series. It is very popular and has a very good response and feedback among the market, because Ricoh have this this kind of a very strong the spectral analyzer product before. So we need to leverage the previous experience of the 800 series spectral analyzer and upward to the RSA3000 series. So we also including the 1.5 gigahertz model inside the 3000 series. So it is because we have the 3015N series. Yeah, and the 3015N series, we also have the we can also implement the real-time spectrum observation and the EMI options, and we can also implement the digital demodulation capabilities and vector network analyzer and so on. Yeah. So we also have the very important part, that is the calibration kit. Yeah. So the calibration kit, we have two models. The first, the one is the CK106A series. the frequency can be up to the 6.5 gigahertz. So if you want to quote for the RSA5000 series, you can just quote as the CK106E series. What is the E means? That means the economic type. So the frequency can be just upward to the 1.5 gigahertz. Yeah, so we have the two categories calibration kit accompanied with our network analyzer series. So that is the function list of our network analyzer. Yeah. So you can see now we have the S11, S21, DTF, and we have the device under test. We can implement some kind of a test for the antenna, amplifier, filter, attenuator, cable isolator, yeah, etc. So this is the product portfolio. So I will not go through for the detail for each kind of the product portfolio, because I think I will pass forward to the presentation slide after the meeting, okay? So I think I have quickly, rapidly go through for the presentation sessions. I will now go through I will swap to the real demonstration sessions and let you know the real demonstration of the spectrum analyzer. So have you seen my real demonstration screenshot?
Yes, we can see it.
So you can see my instrument, right?
That's correct, Edward.
Okay. Okay. So now we will switch to the that is the spectrum analyzer, including the network analyzer options. Yeah. So you can see this is the model number. Is the RSA5000 series spectrum analyzer with the network analysis options. Yeah, so we can see if you want to know more about the feature of the real-time spectrum analyzer, you can press the mode. Yeah, you can see we can have the general purpose spectrum analyzer at the first one. And if you want to monitor the transient signals or some kind of a hopping signal of the wireless communication, you can use a real-time mode spectrum analyzer instead of the general purpose spectrum analyzer. And we can also have the EMI test features and the VNA options inside here. Yeah, so for this kind of product definition and positioning among the market, I need to say, because this product is not a dedicated network analyzer, yeah, compared to the Keysight or the Rohde Schwarz or some kind of the famous the brand such as Anritsu, yeah, etc. So because it is accompanied with the real-time spectrum analyzer, so this is a +1 features add on the spectrum analyzer. So if the customer or some kind of the professor or student want to verify the RF microwave transmission system, so you can use this kind of a spectrum analyzer to implement the signal verification or the component verification simultaneously. So it is a very good CP value to offer to the customer to enhance the test capabilities among the RF microwave or the wireless communication laboratories. So now we can start the demonstration. So for the first, you can press these options and we can show the network analyzer, the interface on the screen. Yeah, so you can see this is the Smith chart, and this one is the polar chart, and we can also have the S11 log magnitudes diagram and the S11 SWR diagram as well. So for the first step, you can see we have the calibration kit here. Calibration kit, open, short, load. Yeah, 3 calibration kit here. And today we will have a antenna here to do the S11 VSWR verification for you as a reference. So now for the first for the first step, yeah, we can do the open short load calibration here. So you can press the measure setup here. Yeah, for the first, you can set up the frequency, yeah, from the 10 megahertz to 1.5 gigahertz. And at the same time, we can set up the sweep point. Yeah, if you want to get more accurate the testing result, you can set more points here. For example, you can set for the 601 point and press the OK. And now we can start the calibration first. So we can press the measure setup, and here is the align here, press here, and you can see the open short load here. So now we can do the open calibration first. So for the open, you can press the open here. So it is very quickly to finish the calibration. Yeah. So first, for the second step, we can put on the short calibration kit at the front panel at the second step. You can press the short here. Okay, it is finished. So for the third step, we can hook up the load calibration kit. So for the load calibration kit, that is the 50 ohms calibration kit. That is to verify if the 50 ohms impedance match can be centralized at the polar chart and the Smith chart. So we press the load here. Yeah, so the calibration finished here. So finally, we can press the down here. Okay, you can see the central point has a 1 point, yellow point here. That means we have a better impedance matching now. So we can start to do the antenna test then. So now we can use this kind of antenna here. Antenna here. So hook up the antenna at the front tracking generator port. Okay, now you can see this is the test result on the Smith chart and the polar chart and the VSWR S11 information and the VSWR. So if you want to observe the information on the display in more detailed, you can press the amplitude to do the auto scale here. Auto scale here. Okay, so now you can see the 4 markers on the display at the Smith chart, polar chart, or the VSWR part. So you can see if you want to press the marker and press the frequency, and you can adjust the markers step here. Markers information. Yeah, you can see the resonance point is around the 70 megahertz here. So the resonance frequency point is at here 700 megahertz here. So you can also verify the Smith chart information or the polar chart information simultaneously. So if you want to get more information, you can press the marker and turn on the marker table here. Yeah, you can get the Smith chart parameters on the marker table here. Yeah, so that is the brief demonstration of the Smith chart and the VSWR information accompanied with the simple antenna demonstration. So now we will switch for the second demonstration, that is the DTF demonstration. So what is the DTF demonstration? That is the distance to fault applications. So we can switch off the marker table first and press the measure here. You can see we have the S11, S21, or the DTF here. So we press the DTF here. Before that, we need to also do the calibration. Yeah, it's the open short load applications. So because previously before the presentation, I have already done the calibration, so we will eliminate and avoid this procedure and help you to quickly to verify to see the demonstration quickly. Okay, so now I find one meters a cable here. Yeah, so we can hook up the N-type terminal on the front panel here. Okay, now you can see this is a default point, interrupt point here. So we can also press a marker here and use a single one because this is a touchscreen capabilities. You can move the marker, use one finger to here. Yeah. So you can adjust the frequency here. So okay. So it is roughly, you can see the length is the 1.19 meters, and we can also have the amplitude information. Yeah. So that is the interrupted point measurement demonstration. Yeah. So besides of that, you can see we have many kind of the information you can see on the display. Yeah. So you can use a trace here to change the information. Yeah. For example, if you measure the S11 information here, so you can change the interface trace. Yeah, such as press the linear one trace format. We can have a log magnitude, phase information, group delay, Smith chart, polar chart, linear magnetically, or the VSWR. So for the second page, you can see the real part, imaginary part of the Smith chart as well. So that is the brief demonstration of the network analyzer. So any questions from your side? So I hope you can raise up some questions and give us some feedbacks. And because Regal company is a very aggressive company, so we invest in more product features in the future. So we also need all you guys and all clients to give me some kind of feedbacks or some information to help us to grow up quickly, accompanying with the customer. Yeah. So any questions?
Edward, I will have a look. I will have a look at the units, and then I'll pose a few questions to you later on by mail. On that, like I said, we are going to be running a special on this and advertising this unit going out, and I will keep you posted on that as well.
Okay.
Okay. But otherwise, it looks like a great unit. I will definitely look more into this unit and seeing customers that will be requiring this
Okay.
this vector network analyzer and all the options with it. We'll be doing the promo going out with the free compliance software going out. So we'll see how that goes. What inquiries we get back from this.
Okay. Okay. So if you have any technical questions, welcome to discuss with me, or all you guys can send an email to me in the future. And for the sales issues, Ted Lin, my colleagues, will also help you to resolve any kind of sales issues or sales questions, including some of the price issue or the service issue. Yeah, welcome to discuss with us. Yeah, so Ted, if you have any questions, want to deliver to all you guys?
Okay. I'm really appreciate Pro-I give us this opportunity to invite a customer to our meeting, this webinar. And thank you, Raymond. Thank you, Neil. And if you want to have other topic or want to know other technical technology, please feel free to let Raymond and Neil to deliver the information for us. And we are happy to have your to give you the other webinar. So do you have any questions with us?
I have to say we have many kind of application applicated oriented materials such as Internet of Things or the automobile electronics or some kind of the RF microwave, the digital modulation application topics. So I previously I passed some kind of a topic to Ted. I thought he has already passed for the Raymond. So I think you can, if you have any interested topics in the future, you can tell to Ted, and we can discuss in further to discuss which kind of the topic can fit your current requirement in your current job or current research or development process. Okay.
Yes, I think it's a great idea. I will definitely take it up with Ted and yourself to do the next webinar. I think we should try and do this at least every month or every second month. Keep in touch with up-to-date technology. Get more people to join in on the webinars, and yeah, like I said, Ted's been very helpful with any issues we have, and you know, it's very basic to understand what the customer needs and what you need to add on for software. So yes, the help is always there. 100% support from Regal as always.
Okay. Yeah, because this is the first time we have the webinar, in the South Africa site. So I'm not quite familiar, and more can hold more informations on your side, because I didn't know what is your knowledge level of the customer from the customer. If you have more entry level than introduction or the webinars, we can also deliver this kind of the entry level presentation. And if you have a very advanced or the experienced customer, we can also deliver the more experienced application knowledge as well. Yeah, so we can make for some the tests or the try on in the future. Yeah.
No, definitely, Edward. Yeah, we've got customers all over the board. So from entry level guys doing hobbies, straight through to universities, to telecoms. You've got your military. So everything from beginner to high end.
Okay, no problem. So if you have any request, welcome to discuss with Ted first. and I will discuss with Ted quickly, and we can deploy the webinar policy or the webinar strategies in South Africa very quickly in the future. Yeah, okay. So Ted, if you have any questions or some information you need to deliver to all you guys.
No, from my side, I have no questions, and no, 就结束了。
Okay.
So thank you for your joining today, and I hope everyone have your good health. So thank you for your join, and have a nice day. Thank you for your join. Thank you.
Bye.
Thank you.
Bye. Thank you,
Thank you,
everyone.
thank you.
Thank you very much to join us.
Thank you.
Thank you very much.
Thank you.
Yeah,
Thank
bye.
you, Edward. Thank you, Ted. Thank you.
Thank you,
Bye-bye.
Ted.
Bye.
Bye-bye.
Bye. Bye-bye.
Bye-bye.